Great. Hey, good evening, everyone. All right, so let's get started. So last time we were discussing Hive. So we have covered almost the entire Hive. A few parts are still remaining. So if you have any doubts in Hive, you can just put in the question panel. Okay, and then we can take the advanced concepts. So this part is also discussed already. We will just go through it. Hey Minesh, hey Chaitanya, good evening. Yep. So we are just starting with the advanced concepts of Hive. We have already covered this in the previous session. So when I say advanced concepts, basically the partitioning algorithms. Right? So we have already covered what is static partitioning, what is dynamic partitioning in Hive. We will quickly take a look. There are a few more concepts which are still remaining. Okay, then we will start with HBase. So let's get started. So this was about the joins, correct? So like I had asked everyone last time that everyone is aware with what are the types of joins which are supported in SQL. So there is an inner join, outer join, left outer join, right outer join, full outer join. So everything is supported in Hive. So this is just an example for that. Okay, so we have already covered this. Okay, just to give you a syntax, how do you write it? So this is basically equi-join. So I select something from a table. I'll just take a highlighter. Okay, I select something from a table, table join a second table on. So this is a syntax which is used for join. So you join table A with table B, and in the on clause, in the on predicate, basically, you specify all the join conditions. Now, one thing we talked about last time was the join conditions which you're mentioning, this should only be equi-joins. Hive only and only supports equi-joins. So I cannot join on two columns by using less than, greater than, equal to, these kind of symbols. Hive only allows you to use an equal to sign. That is what is meant by equi-joins. Hive only supports equi-joins. Now, if I want to do a left outer join, so to quickly tell you what is a left outer join, I hope everyone knows it, but still to reiterate. So let's say I have a table 1 and table 2, or let's take an example. So one example is already mentioned here. I'll take another example. So let's say I have a table customers in which I have data like customer ID, customer name. I have a table items which has my customer ID, item ID, and item name. Let's say this is my data. I have a customer ID 1, name is let's say A, customer ID 2, customer ID 3, right? So let's say this is my data. So I have two tables, one is customer, one is items. And in my customer table, so in my items table, basically I'm having a entry that which customer ID bought which item. Okay, now if I do a inner join on both of these two tables, okay, on which condition I would join? I would definitely join on customer ID. So let's say I join my customer table with my items table. What would be my output? Or let's say, okay, I've done something wrong here. Let's say I use here 1. Yeah. So if I join customer table with my items table, I should use here some number, different number. Let's say this is 4. Yeah. So if I do an inner join, so what is the definition of inner join? Basically, if both the columns of both the tables match, it results into a row in the output. Correct? Only for matching cells, it will result into a row. So if I join on customer ID, my customer ID 1 is mentioned here. My customer ID 2 is mentioned here, my customer ID 3. So if you see my customer ID 2, it is not mentioned in the items table. So this particular thing would not be displayed in the output. That is basically an inner join. And what is outer join? So let's say this is my left table, this is my right table. I want to display the non-matches also. Okay, and I want to display non-matches of my left table. I would use a left outer join. If I want to display non-matches of my right table, I would use a right outer join. And if I want to display the non-matches of both the tables, I would use a full outer join. So this is the syntax for outer joins. So if you notice, so if I want to do a left outer join, so I say table name, left outer join, second table name, and in the on predicate, I specify my join columns. So it's similar, same like the syntactically it is same like MySQL, no difference at all. Okay, similarly this is a right outer join and a full outer join. Right? Any doubts in joins, types of joins? This is just like your SQL joins, no change at all. Great. So we have also discussed about partitioning. Now I'll quickly and briefly I'll tell you what is partitioning and why it is required in Hive. So as we know, Hive will always do a full table scan. Like if I specify a where clause in my query, even if that condition is matched, and let's say I have a 10 GB file, and in the 10 GB file, I'm putting a where clause, which will ultimately match, let's say, only 10 rows. So what your Hive will do as compared to your MySQL or any traditional database, your MySQL will directly go to that 10 rows, which should be there in the output, fetch it, give you the output. Right? What your Hive will do on the other hand, Hive is triggering a map reduce job. So what your Hive will do, even if it is finding the 10 rows, it will not stop. It will continue scan the entire file, the entire 10 GB file. So this is what your map reduce will do, right? It's a full table scan. Hive, which is ultimately a map reduce, will always do a full table scan. Now to avoid such scenarios, to make your query optimize, what I can do is I can partition my table. Now when I partition my table, basically partitioning in terms of Hive is nothing but a subfolder. So if I partition a table, let's say on a particular column, as many unique values I have for that particular column, Hive will create those many subfolders inside my table's parent folder. Right? So let's say I have employee data. Right? This is my table definition. I have employee ID, department ID, gender, and let's say salary. Now this employee data I receive, my company is very huge. I receive employee data, let's say every month, right? Let's say every month I receive roughly around 1 to 2 GB of my employee records. Now, over the period of time, if I keep all of these records into a single table, this table will grow very huge. If I want to do some analysis on this table, let's say I want to generate a report which says how many number of employees joined in last month, right? Or if I want to do it on year, let's say how many employees joined last year or how many employees resigned last year. So if I want to create such reports, my entire table is very huge. It contains data from last couple of years. If I just want to check for a single particular year, this Hive query will basically scan the entire data. Let's say I'm just interested for the data which is, let's say, around 5 GB, and let's say my entire table size is 1 TB. So what a Hive will do, instead of this interested 5 GB of data which we are looking for, Hive will ultimately go through all this 1 TB record. So your query would take very long time to finish. Your report will take a long time to get generated. In such cases, what you can do is you can partition your table. Now for partitioning, what I can do is I can partition based on months. So what I can do, I can tell Hive that when I load this 1 to 2 GB file into my table, I can tell Hive that this particular file belongs to, let's say, January 17. What a Hive will do, so this table is basically a folder in your HDFS. What a Hive will do, if you're specifying a partition, Hive will create that as a subfolder and place this file inside that subfolder. What is the advantage you are getting here? So if I query on this table and if I say where this year or month column is Jan 17, what Hive will do, instead of scanning this entire table, 1 TB table, it will just scan the small file. So this is to avoid, partitioning is used in Hive to avoid full table scans. Ultimately, it will bring in optimization. It will bring in speed. Now we have discussed that there are two types of partition in Hive. The one which I just showed you, this is a static partition. The reason is I am specifying while loading my data, I am specifying which is my partitioning column. I am specifying my partitioning column is Jan 17. My data of that column is Jan 17. So this is called as static partitioning. What is dynamic partitioning on the other hand? Your Hive will decide how to manage your data, how to keep your data. So let's say now one thing to note in case of dynamic partitioning, the column on which you are partitioning should be the part of your data, right? So let's say I'm partitioning on year, or let's say I partition on my department ID. I cannot partition on year in case of dynamic partitioning, as my data does not contains a year as a column. It just contains employee ID, department ID, gender, and salary. It does not contains year. So I cannot partition on year if I'm doing a dynamic partitioning. If I'm doing a static partitioning, I can specify a column to partition which is not a part of your table also. Okay, so if I'm doing a if I'm doing a dynamic partitioning, what a Hive will do, let's say I partition on department ID. What a Hive will do, your Hive will check how many unique departments I have. Let's say I have 3 departments, 10, 20, and 30. My table folder is EMP. What a Hive will do, it will automatically create 3 subfolders. One for department ID 10, one for 20, one for 30. All the employees which belong to department ID 10, the file would be stored here. For 20, the file would be stored here. For 30, file would be stored here. Now this is not us who is deciding the partitions. You are just deciding the partitioning column. The actual values you are not deciding. That is Hive who is deciding it. This is called as dynamic partitioning. Now one thing to note in dynamic partitioning, the partitioning column should be such that the values are repeated, or you can, in other words, you can say the values are skewed. All right. I cannot partition on employee ID. What this will do, let's say I have 10,000 employees. Every employee ID is unique. So it will ultimately create 10,000 subfolders. And in every subfolder, I would be having a single record. So in the employee ID one subfolder, I would be having a file which will contain a single record for this employee ID. Everyone agrees to this? Great. Right. So you should always partition on such columns which are repeated across your data. So even if I have, let's say, 5 employees or 5,000 employees or 5 million employees, I have only 3 department IDs. Yeah, so Shiv Prasad has a question. In dynamic partitioning, the repeating column will handle it. Shiv Prasad, I'm not sure about this question. Can you just rephrase the question? Right, so until you are typing, okay. So Shiv Prasad says, in static partition, you are saying repeating columns should be selected. Yeah, so Shiv Prasad, it's in both the cases. It's overall at the partitioning, this entire thing which we have called as partitioning, this is valid for the entire partitioning thing. May it be a static partition, may it be a dynamic partition. The partitioning column should always be such that the values are repeated. So that's what I was discussing. So if I have 5 employees, 50 employees, or 5 million employees, I only have 3 department IDs. So ultimately, if you consider at the HDFS subfolder level, I would be having only 3 subfolders. One for 10, one for 20, one for 30. So you should select such columns which are repeated. When I say the columns are repeated, that means the values of that columns are repeated. Now, can anyone tell me what should be or what can be another candidate from this particular columns which I can use for partitioning? Great. So everyone says gender. Exactly. Right. So I have only 2 genders. So if I partition on gender, ultimately at my HDFS level, I would be having only 2 subfolders. Now, when this gender partitioning would be helpful, when your queries are such where you're using this gender column in your filter clause, right? Always remember partitioning. Yes, it will optimize your query performance, but the condition is your query should have a filter on the partitioning column. So if I am partitioning on department ID and in my where clause, I'm putting a where clause for gender. This will not optimize my data. This will still do a full table scan. The only way when my data would be optimized, when my query would be optimized, would be I would partition on department ID, and in the where clause, I use the department ID. Right. So Chaitanya says, can you alter partitioned column on a table? Yes, Chaitanya, I can alter table and change the partitioning column, but the underlying data will not change automatically. So it's up to you. How do you manage the underlying data to apply to your new column structure, new schema? The only mandatory thing in partitions is on whatever columns you are partitioning, that is always the last column of your data. Right? Partitioning column is always the last column of your table. All right. Now let's say there is a case where I am very new to Hive. I'm using Hive for the first time. And accidentally, let's say I have a file, same employee records, and I have 10 million employees. I have a huge file. Accidentally, I create a partition table and a partition on employee ID. What will happen? I have 10 million employees and I partition on employee ID accidentally. Yeah, so Rahul says 10 million files would be created. So not 10 million files, 10 million folders. Partition is a subfolder, right? Yes, exactly. So Bhaskar says 10 million partitions would be created. Now 10 million folders in HDFS. Your entire HDFS, your entire metadata will increase, right? Every folder or a file may be empty. It has a metadata. Correct. So when your metadata is increasing, that means your load on your name node is increasing because this entire metadata is hosted by your name node, right? So it is a possibility that your name node may crash, right? Your HDFS master may crash due to out of memory limitations. For such reasons, dynamic partitioning, it is by default switched off in Hive. All right, dynamic partitioning is by default switched off in Hive. Now, if I want to do a dynamic partitioning, you have to turn it on. So why Hive is doing this way? Just to avoid such conditions. So accidentally, if you do it, so Hive is basically giving you a warning that please check, are you partitioning on the right column or not? Right? So to enable dynamic partitioning, there are a few properties to set. Now the properties are, you have to specify hive.exec.dynamic.partition.mode and you have to set it to non-strict and you have to enable dynamic partitioning. All right, and the other two properties are for buckets. So this is how you create a partition table. So you say create table, table name, you specify the columns, and then ultimately you say partitioned by, and then you specify which column you are partitioning. This clustered by is used for bucketing, right? So this clustered by is not a part of your partitioning, it's for bucketing, right? Loading data into a partition table. So you can say insert override table and you specify partition, which partition you want to insert the data. You have to always specify that if it's a partitioned table. Okay, now the best thing with Hive is, though Hive is writing a MapReduce job, ultimately your queries would be converted to a MapReduce job, right? Apart from this, if you want to plug in some extra processing. Okay, so Minesh says insert overwrite is syntax. I didn't get that, Minesh. So do you want to know the insert override syntax used in Hive? Yeah. It's same like your SQL. So if you say insert into table name and you specify a select query, that will just insert data. And if that table already contains data, you don't want to append, you want to override the existing data. So then you say insert override table. So insert override will delete the previous data and write your new data. So both are supported in Hive. You can insert into a table or you can insert overwrite a table. All right. Now one best thing with Hive is you can plug in custom MapReduce jobs with your Hive scripts itself. Now see, ultimately Hive is, okay, so Chaitanya says, can I insert without deleting? Yes, Chaitanya. Insert into this particular statement will insert without deleting. Okay, so when I say insert into a table and I specify table name and a query, this will not delete the previous data. If I want to force to Hive that delete the previous data, then you specify insert overwrite. You add one more predicate, you add override. Okay, so Chaitanya says it will add the records at the end. Yes. So what Hive will do basically is for every insert query, so let's say this is my Hive table, let's say EMP, it already contains some data, some 3 files. When I insert into this table from a particular query, select something, something, whatever the output of this query is, ultimately this would be created as a file in your table. All these files combined becomes your table data, right? All the files combined becomes your table data. So when you insert into this, Hive will not change the existing files. See, ultimately it's HDFS. You cannot change, you cannot modify, you cannot update an existing file in HDFS. So Hive will basically just add one more file, new file, inside that table directory. Right? And if you do a select star, ultimately this file would be read late at the last. So it would, you will get a feeling that it is added at the last of your table. Okay, but ultimately it's a separate file. Okay, so this reminds me of one more thing. In Hive, there is no query like truncate table, right? You cannot truncate a table in Hive. Now what is truncate? What does truncate do? All right, so everyone's okay. Great. So everyone says it deletes all the records, but it maintains the table schema. The table is there, all right, but the table is there. Sorry, the table is there, but the data is not there. Oh, Kishore says drops and recreates table. No, Kishore, it does not drops and recreates. It just deletes the data. Table is still there, right? So basically it will empty your table. Now in Hive, there is no syntax called as truncate table and you specify a table name. There is no syntax like this. If we want to truncate a table, what you can do is you can go to your HDFS, delete all these files from your tables folder. Right? Missing files is basically no data. Okay. So if I delete all these files from my employee folder, ultimately my table, which is pointing to this employee folder, will get 0 data. That is truncate. You cannot do this through a query. Okay. Now let's say I want to run a custom MapReduce script. So here is an example. So let's actually read this. So Hive query language allows traditional MapReduce programmers to be able to plug in their custom mappers and reducers to do more sophisticated analysis that may not be supported by built-in capabilities of the language. Now, if you take an example, so I have a table which has user ID, movie ID, rating, and timestamp. Now let's say I want to do some custom processing. I load this table to my Hive. I create this table, I load my data. So I say create table, I specify schema, I specify my delimiter, I load data. This is how I can I can create and insert my custom mapper. So basically, let's say I'm writing a custom mapper to convert timestamp to weekday. Now if you see my data has timestamp, I want to convert it to a day. So either I can use a UDF, correct? I can also write UDFs in Hive. So either I can use a UDF. Most of the cases you will write a UDF for this. Invoking custom MapReduce, writing a specific script for this, it may be used, may not be used. So you have two options for doing this. Either write a custom MapReduce script or write a UDF. Now how will I do it? Minesh, you would be interested in this, Python. All right. So I write a Python mapper. Right? Yes. So I write a Python mapper. So what I'm doing, I'm stripping my line, okay, based on a I'm stripping as in I'm removing all the white spaces. I'm splitting on the basis of a tab, all right? And I'm getting the weekday. So I'm using a Python library to convert timestamp to a weekday. So this is just a normal Python code which I have written, right? This is how you write a mapper in MapReduce in Python, all right? Now, let's say I keep this data, I keep this code inside a file called as weekdaymapper.py, all right? Now, how will I use this? So first, my Hive should know that I'm adding this file. My Hive should have access to this file. So I will use a command add file and I'll give the path of this file. The next thing I would be doing is there is a clause called as transform. So whenever you are writing a custom script, a custom mapper or a reducer in Hive, you have to use the clause transform. So my query will become like this. So I say insert override table, I give the table name, select, and I'm calling the transform clause, right? I'm transforming this particular data, which is already my tables data, using my Python script, right? So I just invoke, like I invoke the script from a normal shell, Python, and I give the path of my file, name of my file. Similarly, using Python, you give the name of the file, right? So whenever you're writing a custom mapper or a reducer, you have to use this transform class. Okay, so this is one way of invoking your custom code through Hive. The second and the simplest way, according to me, is using a UDF, right? So it's your choice. Okay, whatever you prefer, either you can write a UDF or you can write a Python mapper or a reducer. All right, so this is my output. Right. Now, how do you write a UDF? So we have already discussed this. You have to just overwrite. You have to extend your class. You have to write a class first, which extends from UDF. Right. Now, this UDF is basically a Hive class, Hive provided class. You have to write a method evaluate. Okay, so if you just look at this particular sample code, it is basically converting your string data to lowercase. So the method is very simple, right? You just say if s is null, return null, or else return convert to string and convert to lowercase. That's it. So it's very simple. You have to just write the evaluate method and do whatever processing you are writing that UDF for. How will I use a UDF? So I will convert this sample code to a jar file. All right. I will add this jar in my Hive. I'll say add jar and I'll give the path of this jar. I will create a temporary function. Right now, this particular syntax is wrong. Actually, it's not create function. It's create temporary function. Right. Hive does not allows you to create permanent UDFs. So I say create temporary function. I give a function name as, and I give the class name of this custom UDF, right? If you're writing it inside a package, it should be fully qualified class name. So I'm writing it as com.example.edu.udf.lower. This is how you refer to a particular class in Java. And how will I use it? So I've registered my function as edu_lower. I can use it in this way. Select edu_lower, give a column name, group by edu_lower, give a column name. So this is how you use a UDF. This is a pretty straightforward and a simple way of writing it. Yes. Okay, so Minesh says through Hive. No, Minesh, it's written in Java, right? It's not written through Hive. I cannot create a function in Hive using HiveQL itself. So it is not like Oracle. So Oracle gives you something called as PLSQL, right? In which you can create your functions using a specific language which is supported by Oracle. That's PL/SQL. Hive does not support this functionality, right? Usually other databases, they allow you to create a function using SQL, but Hive does not, right? You have to either use Python or Java. right? Now this is index. Now what are indexes basically? So this is one more thing for optimization. Now Hive, when it was developed, Hive did not support indexes, right? But as latest developments are happening in Hive, indexes are supported, right? Now, so these indexes, you can consider this to be similar to what happens in your MySQL or a traditional database, but still it is not as fast as your MySQL. So though you can create an index in Hive now in the latest versions, it would definitely improve the performance of the query, but not to an extent like your MySQL or your Oracle does. Using indexes in Hive is still slow, all right? Creating an index is a slow process. Querying a column which is already indexed, that is also a slow process, but it is faster than a non-indexed column, right? So you cannot say that if I index a column, my output would be real time, right? It's not real time. It's just fast. It's just optimized, right? So it is just a method for optimization. Hive indexes are used to speed up the access of columns or set of columns in Hive database. One more thing, this is the latest functionality added in Hive. This was not available in previous versions. All right. Without an index, the database system has to read all rows in the table to find the data you have selected. And if you have an index, it can basically search in that particular row. Okay, so difference between having an indexed column and non-indexed column. If your column is indexed, it can do a search. If your column is not indexed, it will read the entire column sequentially. That's the difference. Okay. Now it is available from Hive version 0.7. Maintaining an index requires extra disk space, and building an index has extra processing cost. If your table is very huge, and if you want to create an index, your creation of index also takes a lot of time. Again, it triggers a map reduce job for doing that. It takes a lot of time. When you should not use an index, so let's say my data on a particular table is getting increased at a very high rate, right? So let's say I have a data and every day 2 GB, 3 GB is getting added to that particular table. In such cases, you should never use an index, because whenever you change data inside the particular table, you have to re-index the table. Re-indexes comes at an extra processing cost. So it will take extra processing time, it will take extra disk, all right? So Hive indexes, though it is available, very rarely used. Okay, it's not used in full-fledged. Okay, so it works with internal table, external table, and partition table. This is just a syntax for creating index. So I can say create index name on table. You have to specify a table name. As this is a index builder, index handler in Java, which is again a Hive class, Hive provided class. And there's some properties you can specify. Okay, everything in square brackets are optional. All right. Okay, this is fine. I'll just read through this. What are the responsibilities of your index handler? During create index, validating the format of base table and then generating the structure of the index table and filling any additional information in the index storage descriptor. These are just the functionalities. I don't think it's very important. Okay, it's not very important. Okay, so we can actually skip this, but still we will read. During rebuild, producing a plan for reading the base table's data and writing to the index storage or index table. During drop, deleting any index specific storage. During queries, participating in optimization. This is what a typical index do, right? Okay. Views, right? So everyone knows what is a view, or is there anyone who does not know what is a view? Okay. Now Manish says again, this is in version 7. Entire indexing, yes, indexing is in version 7, not the views, right? Views are available from the first version of Hive. Okay, just an additional info. So Hive, if I talk about Hive versions, right? So it started from 0.1, it went until 0.9, but uh, in 0.9, they did some additional thing in Hive, which basically forced them to do a major release. Okay, so basically in version 0.9 onwards, they have added Spark functionality in Hive. So what they did is they renamed the version 0.9 to Hive version 1.0, right? They did a major version change, right? This is for those who know what is the difference between a minor version and a major version, right? Okay, now what are views? Okay, so Shifra says, how can we get all these version changes? Okay, so Shiv Prasad, if you go to Apache's website for Hive, there's a specific page in which it tells you all the versions, and every version has a specific README file. So it will tell you what are the differences between this version and the previous versions. So it is there in the Apache's website itself. Okay. All right. Now, what are views? So basically, view is, you can consider view to just to be a virtual table. Okay, Shiv Prasad says it can be asked in interviews. Not really. Okay, this version information is not really asked in interviews. Okay. This could be asked that on which version of Hadoop you have worked, because Hadoop's version matters, right? If you're working on Hadoop 1 and Hadoop 2, there is a huge difference. So in Hadoop 2, basically, if your interviewer asks you this question, basically is interested to know if you have worked on Yarn or not. That's why he asks you on which version of Hadoop you have worked, right? So you should say the latest Hadoop version, right? I think the latest is 2.8.2, according to me, yeah. Okay. Now view is basically a virtual table, right? So let's see what is a view. I have a table which contains, let's say, 10 columns. Yeah, so Shiv Prasad says logical window of the table. Exactly. Right, I'm explaining the same thing. So let's say I have 10 columns inside a table. Column 1, column 2, column 3, till my column 10. Now let's say I have 3 different set of users. Right? Let's say I have developers, I have administrators, and let's say I have my clients, my business users. Now let's say out of this 10 columns I have in my table, for my developers, I don't want to show them the entire 10 columns. I just want to show them column 1 to column 7. For my administrators, I need to show the entire 10 columns, right? Or let's say I don't want to show the column 1. So from column 2 to my column 10, I need to show them. For my business users, from my basically my clients, I need to show them the entire table, but let's say not in the same format. I want to show column 2 first, column 1 as second, then column 10, and column 7, and so on. I'm changing my column sequencing. So what do you think? Should I be creating 3 different tables for these 3 users? Right? Yes, exactly. Sanip says no. So what you can do is, in such cases, you can use view. Exactly, you can use view. Now what is a view? View is just a select query. Consider view to be a select query. See, ideally, if you talk in terms of a database, a traditional database, there are 2 types of views, right? Now, if you talk in terms of Hive, there is only a single view, that is a select query. All right, your traditional databases gives you a view called as, I'm not recollecting that name. Yeah, these are called as so anyone knows what are materialized views? Yeah, so basically materialized views contains data. It is a snapshot of your table. Yes, Bhaskar, right? Exactly. It is a snapshot. Materialized views contains data. But in Hive, your views does not contain data. It points to your table, right? It is just a select query on your table, right? So Hive does not support materialized views. Okay. Now what I can do in this case is, for my developers, I can create a view, select column 1 till column 7 from this table. Similarly, for my administrators, I can create a query. My business users, I can create a query. It's just a select query on my original table. That's a view. Okay. The best part about views, so if you say show tables, views are also is a output in that particular query. So views are also displayed in your show tables query. Okay. If you describe a view, okay, like I can describe a table. If you describe a view, it will tell you the actual query from which that view is built. All right. So view is just a select query. So a view allows a query to be saved and treated like a table. It is a logical construct as it does not store data like a table. Views are supported from Hive version 0.6. No, actually it was supported from the first version itself. So the statement is wrong. It is supported from the first version. Yeah, so Rahul says we can use UDF while creating view, right? Yes, Rahul, we can. Right? So while creating views, let's say you want to change the case, or let's say you want to aggregate on a particular column. Let's say your view is very complicated. So you can write a very complicated query and register that as a view. Yeah, so Minesh says, is there any UI tool to check how that view is built or how to, okay. So if you're using Apache Hive, right, the version which we are using, there is no UI tool available. Okay, but as I mentioned that Hadoop is being sold as a product by multiple companies. Correct? You have a company called as Cloudera, MapR, Hortonworks. Now what these companies have done, they have built a beautiful UI on top of Hadoop. Okay, so for example, if you consider Cloudera, right, it has built a tool. Cloudera has built a tool. I'll just name that. It's called as U. I'll just type it. Cloudera has built a tool called as U, H-U-E. It actually stands for Hadoop User Experience. Now what this U is basically, it is basically a user interface through which you can write Hive queries, through which you can write pig queries. You can browse your HDFS. Okay, up till now, so we had a UI for HDFS, right? But that was a read-only UI. Okay, you can just check how many files are there. You can download a file. All right. Amazon EMR. So Minesh, Amazon EMR does not gives you any UI. It is just giving you Hadoop, but no, without any UI. Okay. So what it gives you ways to interact with your HDFS. Like you can upload a file through you also. You don't require shell at all. So if you're using Cloudera, Hortonworks, or let's say MapR, you don't even require a shell. All right, you just open a UI, you can upload files through UI, you can download files through UI, you can change permissions, you can rename a file, move a file, copy a file, everything. You can write a Hive query, you can drop a table, create a table, everything you can do through UI. Okay, if you want to get an experience how to use, how this U looks like, okay, you can just write this website, getu.com. It will give you a live demo of U. So it will give you a live view interface in which you can get the feeling how to use view. It's very simple, right? Okay. So views are kind of virtual tables. You can apply all DML operations. Okay. Uses views reduce query complexity. It encapsulates the complexity, so it is very easy to understand for the end user. Views restrict data based to used by different users, but currently this feature is not fully supported. Okay, this is actually supported now in the latest versions. So, okay, summarize data from various tables. Okay, to generate reports. Fine. How to create a view? Create view. This is optional if not exist. You can give a view name and give a query. Right? Views are read-only and may not be used as a target for loading data, inserting data, or altering. You cannot. So you can alter a view and change the query, but you cannot change the data types or the column names or some things like that. Okay, you cannot insert data into a view. Okay, that's just like a normal database. It's a read-only table, virtual table. Okay, some syntax. Okay, all right. Now you can connect Hive through your JDBC also. So Chaitanya says, unlike traditional, which supports insert view, I doubt. In traditional database, can you insert into a view? Yeah, you cannot insert. Chaitanya, you cannot insert into a view, right? May it be traditional database or Hive, you cannot insert it, right? Some databases might be supporting it, right? But standard databases like Oracle, Teradata, MySQL, that does not support. Chaitanya says, is view faster than table in Hive? So Rahul, uh, view is just a query. So if you create a view, it will not trigger anything. So let's say I say create view and I give a very complicated query. Nothing would be triggered. If I select from that queue, from that view, your query is triggered on the actual table, right? So it's your query. So even if it's a view or not a view, the actual query is getting triggered on your original table. So there is no difference in speed. Okay, it is just abstracting your complexity. So let's say so if you talk in terms of the lines used in your queries. Okay, so let's say I have a query which is 1,000 lines. It's a very huge query, right? Let's say out of the 1,000 lines, I modularize the query. For first 50 lines, I create a view. For next 50 lines, I create a view. Okay, so basically your entire 1,000 lines would be rolled up to a very small and simple to understand kind of a query. Okay, so let's say I have a query which is doing a select some columns from a subquery, and the subquery is also a select, and it's a very huge subquery. Okay, so the understanding this huge logic is very difficult. What I can do is I can pick up this subquery, create a view for this, and ultimately my final processing query will look like select star from, and I can just use my view in this particular subquery case. So my query complexity in terms of look and feel will reduce. It will become simple for me to understand. Right? Again, one thing just reminded me, Hive also supports subqueries, which are not mentioned in the slide, but Hive also supports subqueries. Right? A subquery, just to define it, a subquery is query within a query. Right? Everything, so Hive supports everything. Right? Okay, so we can connect Hive through your Java also using JDBC. Okay, the same way like you connect to your MySQL database, your Oracle database. Similarly, you can write a Java JDBC code to connect to Hive. Now for that, you have to start an Hive server, right? You have to start a Hive server. Okay, because if you notice, Hive is just a language layer, right? It is just converting your normal queries to a MapReduce job. It's just a client, okay? But if you want multiple other clients connecting to Hive, okay, I can have clients like a JDBC code which is connecting to Hive. I have to register Hive as a server that is already given by your Hive. Okay, so there's a command, with this command, Hive service Hive server. This will basically start a Hive server, and to this Hive server you can trigger your JDBC codes. All right, and how to write a JDBC code? I think everyone knows it. So this is your driver name. Okay, so if anyone has an experience of writing a JDBC code for, let's say, MySQL, so for MySQL, what is the driver you use? com.jdbc.mysql.driver, correct? Like if anyone has experience. So similarly, this is a driver name for Hive, right? And this is the host on which your Hive server run. So the host where I'm starting it, that's the local host or any remote host it can be. And the port is 10,000. That's a default Hive server port, 10,000. Okay, this is the same Java JDBC code, right? No difference. Okay, so Rahul says, when will you do this? Okay, so let's say I'm writing a application. Let's say you can consider this thing. So I'm writing an application for storing and retrieving my employee records. Okay, I have different types of users who does not know SQL. Okay, I want to create a UI. Okay, where I just click a button and this will give me how many total employees are there. Okay, if I want to add an employee, it will give me a button which will generate a form. I can enter my details and I can upload that employee. Okay, if I want to build such a functionality, it's not directly going and triggering an SQL, right? If I click a button, so at the back end, I can write a Java JDBC code which will ultimately take that data, give it to Hive, submit that data to Hive. Now for such cases, you should require a connectivity to Hive, and that is through JDBC. All right. Yeah, so Chaitanya says, does it has ODBC? Yes, Hive also gives you an ODBC driver also. Okay, so it has an ODBC driver and a JDBC driver both. Okay, so this is just an additional thing. So as part of an assignment or a project, you have to do a project in Edureka, right? So it's there in your batch LMS. They have a problem statement, they have your data. Okay, and based on that, you have to create a project. So this is for everyone. Okay, so you can start doing the project. Okay, I'm not sure what the project is really all about, but it's basically XML files, and you have to use all your Hadoop tools. For example, your HDFS for storing, you can use Pig, Hive, Scoop. All right, you have to use all your Hadoop tools and complete that project. Okay, this is a certification course, right? So once you are completed with your project, only then you will get your certificate. All right. So this is just about your project. So you will be having raw XML files. You will store it to HDFS. You can do some processing in Hive, some processing in Pig. Right. After doing some processing in Hive, let's say you want to create reports on that. So the processed data, you will put it to a MySQL database, right? And for doing that, you would be using Scoop. This is just about your project. Right. So any doubts with Hive? Okay, now which, just a typical survey, which do you find simple, Hive or Pig? Everyone says Hive. Yeah, so actually Hive is simple. Okay, see, it's language. In terms of language, you haven't learned anything new, right? There is nothing new in Hive. Okay, it's just a language which is same like your Oracle, MySQL. The only thing is architecture is different. But if I'm a newbie to Hadoop, I know MySQL. I can use Hadoop anytime using Hive, right? So Hive is pretty simple. Okay, Manish says yes, but again, it is only for structured data. Yes, that's a limitation of Hive. It can be only used for structured. For unstructured, you have to go to either Pig or through Java MapReduce. Right? Yeah, Pig is also good. So Chaitanya says not real time. Yeah, so overall Hadoop, if you talk in terms of Java, MapReduce, Pig, Hive, all of these are not real time. Nothing is real time. All right. Now let's start with NoSQL databases. So before starting with NoSQL databases, let's take a small break. Right? Let's take a 5-minute break and then let's start with NoSQL. That's your edge base. Okay, so if you have any questions, you can just put it in the question panel. I'll just set a timer. All right. So Chaitanya says, where can I get jars for Pig UDF in Edureka's site? So it's in your LMS itself, Chaitanya. There is a link which will tell you how to download these jars. I think there are 2 jars which are required. Okay, so you will get it under the Pig module itself. There is a link. Karthik says, how about recording for this session? Will it be uploaded in LMS? I need to check with the team. The session is getting recorded. I think it would be uploaded. Next 3 sessions, I think it should be uploaded because this is getting recorded. Yeah, I know the previous session was uploaded in session 10. Yeah, I know. Okay. But definitely you will have access to this recording. I am not sure where this would be placed. Okay. Yeah, so Minesh says, what is Kafka? All right, so Kafka, Minesh, it is a streaming tool very similar to Flume, right? You can consider Kafka to be a message queue kind of a thing, right? You post some messages to Kafka and you can retrieve those messages at a later time. So it is used for streaming data, right? Very similar to Flume, but it is more advanced than Flume. Okay, it's an advanced tool which is created by Apache. So let's say if you want to do real-time processing, this is the best mixture, right? You use Kafka and Spark for real-time processing of data. This is the best combination to be used. Kafka is not a it's not a part of Edureka session. There's a different course for Kafka. Yeah, so Manish says I hear these new tools every day and kind of getting lost. Yeah, so actually the list of tools is very vast. In fact, every month 2 to 3 new tools are added to this ecosystem. Okay, so the list is very huge. A single person cannot learn everything. So the best thing is the base for everything is your HDFS MapReduce. Okay, so if you know core Hadoop, the tools are just meant to simplify your life, to simplify some of your use cases. So it's just a matter of syntax, how to use a tool. It's just a matter how do you configure a tool. Ultimately, the main logic is your HDFS and MapReduce. Right? That's why we concentrated more on HDFS, more on MapReduce. Right? Okay, so Rahul says for PDF reader, any tool available or needs to write custom Java code? Yes, Rahul. So you have to write a custom Java code for reading a PDF file. So with PDF, you already have few of Java libraries which can read PDF. Okay, so you have to write a custom Java MapReduce in which you will import that particular jar, that particular library for reading PDF, and then you will be coding it. Right? So this is true for reading a PDF also, for reading in a Word document, an Excel document. It is true for everything. Right? So if you have any questions, you can just post it. I will be back in 1 minute. All right, guys. Yeah, so Chaitanya has a question. Chaitanya and Rahul has a question. I hope both are back for me to answer the questions. Chaitanya, Rahul, you're back. Yeah. So Chaitanya has a question. For Cloudera certification, do we need to know any language? Not really. Okay, not really. You need to know the tools. Okay, Cloudera would be specifically focusing on the tools. Yeah, but for Spark, all right, Cloudera certification also uses Spark. So you may require a bit of Java and Scala, right? Because Spark is written in Scala, so you would be requiring Scala for Cloudera certification. So Rahul has a question. I can pass directory and MapReduce will read all the files within directory and process with same logic, right? Yes, Rahul. You can pass a directory to MapReduce jobs. You can pass multiple directories also. So let's say I have 2-3 directories placed at different locations. I can pass everything. The files inside that will become the input to your MapReduce job. All right. Cool. So let's get started with NoSQL. I'll just display a few images. Let's see. So just tell me what issues you see in this. Okay, so let's say this is the first image. Okay, this is basically a social network, right? Twitter. So if I want to, so what usually I have in Twitter, I have how many tweets, how many are following me, right? How many followers I have, how many friends I have, recommendations, okay, kind of these things, right? If you talk about LinkedIn, all right? So the same thing, right? Uh, how many friends I have, the um, messages which I'm getting, the comments, the personal messages, friend requests, right? Search bar which I have, okay? By the way, this is Duff Cutting, right? Who is the father of Hadoop, right? And remember I was talking about Arun Murthy. So this guy is Arun Murthy, pretty young guy, and he has a major contribution in developing Yarn. Right? The next image is Facebook. Again, the same kind of a problem. Okay, I am a user, how many friends I have, all that kind of issues. Okay, now can I solve these issues using a traditional database? Can I have a mapping of how many friends I'm getting, or let's say how can I manage how many friends I have, how many messages I'm getting, how many comments my post has, how many likes my post has? Can I store such data in a traditional database? No. All right, so Rahul says no. That's exactly the answer. You cannot store such type of structured, unstructured, semi-structured mix in your traditional databases. Now, for such use cases, you have something called as NoSQL. All right. Now, what are NoSQL databases? So let's go to the next slide. Again, ad targeting. This is another use case. Okay. So what is common in all of these? Huge data, fast random access, structured data. Most of the cases, if you are talking about, let's say, friends and friend request, all of those things, it is structured. But when you're talking about messages, likes, comments, these are all unstructured, right? And every type of data, for example, on Facebook, if I talk about friends, okay, it's basically structured. If I talk about comments, that is unstructured, okay? And the schema of every type of data is different, correct? Or let's say you just consider structured data. So if I talk about how many friends I have, I would manage that in a structured table. If I manage about, let's say, how many pages I am following, that is also a structured data, but the table schema is different, right? If I talk about how many videos I have liked, if I push that into a structured table, the schema would be different. So for everything, for a single user, there would be multiple tables involved. Multiple tables would be having different schemas. So imagine the overhead which your Facebook would be doing if they use traditional database. For a single user, they would be maintaining hundreds of tables, because for every use case, there is a different table with a different schema. Right? Getting the problem statement. Okay. Need of compression. As the data is very huge, there should be, it's better to compress your data. Need of distribution, because again, data is very huge. I cannot store everything on a single machine for a single user, right? I should be distributing my data. Can anyone guess on Facebook, okay, per user? So Facebook did a survey, right? Can anyone guess per user how much data Facebook is storing? Any guesses? Any random guesses? Okay, so Shiv Prasad says 1 TB, Minesh says 10 GB. Okay, so the storage space I'm talking about is what Facebook has allocated to user. So that is the limit a user can use, that much amount of storage, and that storage limit is 5 TB. Okay, it's 5 TB per user, which your Facebook has allocated already. So imagine the amount of data you are generating. Okay. And I cannot store 5 TB per user on a single machine. So data would be distributed. Distributed the same way our Hadoop is doing, storing it across multiple machines. That's a cluster. Okay, that is distribution, distributed data. Okay. So how traditional database will solve this problem? So let's say I talk about connections. So I will be having two tables, right? A user table and a connection table. Okay. This is for one use case. Let's say my use case is different, my tables will change, my schema will change. Okay. So for every use case, you cannot use database. You cannot use a traditional database because though my data seems to be structured, there are multiple structures involved, multiple schemas involved, multiple schemas as in multiple tables involved, right? In such cases, you should always go for NoSQL database, right? Now, what is the best part with NoSQL? This is fine. Distributed data, sorted data, sparse data, automatic sharding. Okay. Now, what is a best part with your NoSQL? So in NoSQL databases, so as the name says NoSQL, it does not mean it does not support SQL. NoSQL actually stands for not only SQL, right? So there are lots of NoSQL databases available in the market. Most of them are free to use. Okay. What is a typical feature of a NoSQL database? So you create tables in NoSQL database also. It also contains tables. Okay, though it is NoSQL, so don't get confused that it is not SQL. You cannot use SQL on a NoSQL database. You would be creating tables. The best part of NoSQL databases is you don't define a schema. A single table, okay, if I talk about HBase also, a single table can contain data with different schemas. For example, if I am talking about the problem, again, if I go to, let's say, Facebook page, if I'm talking about the problem that how many friends I have, how many connections I have, that's a typical structure of table. If I talk about a second use case, how many pages I'm following, there is a typical schema of that table, different schema. Now for normally, I would be creating multiple tables to handle this. If you use a NoSQL database, you would be creating a single table and you can dump every information for that particular user inside a single table. You don't require multiple tables. Okay, this is possible with NoSQL. The reason this is possible is NoSQL databases does not have a schema, right? They do not have schema. You can put any type of data in a NoSQL database. So let's say if I'm talking about connections, I can put my connection data into a single table. If I'm talking about the pages I'm following, I can put the same data into the same table where I'm storing connections. This is not possible with traditional systems. Now, if I'm storing everything in a single table, what problem I can face? My table will grow very huge. Okay, so if my table is growing very huge, your NoSQL databases automatically can distribute this entire huge table into small chunks across a cluster. Okay, so these are some powerful features of your NoSQL databases. Okay, so characteristics of a probable solution: the database should be distributed, which your NoSQL gives you. Data should be sorted, again your NoSQL gives you. It's a sparse data store and automatic sharding. What do you mean by automatic sharding? It is automatically distributing your data. If it does not, let's say my cluster is small, I'm not able to store this data. If you introduce a new machine, it will automatically balance the load. Okay, so it is linearly scalable, just like your any Hadoop cluster, right? If my storage in a cluster is, I'm not able to store much of my data, all the machines, all my data nodes are full, I can add more machines and my cluster will automatically balance itself. Okay, so Minesh says you receive the data faster than you store. Yes, that's one more thing, a good thing, Minesh. So the best part with NoSQL databases. Okay, tell me, is my Hadoop real time? Can I use Hadoop for real-time storage, real-time access, read writes? No. Right? Chaitanya says no. And the right answer is no. The best part with NoSQL databases like HBase is it is real time, right? HBase is a real time database. When I say real time, you can, so let's say my velocity of data is very high. I'm getting data at a very high rate. Your HBase would be able to store that data. Okay, just an example, your Twitter has, your Twitter gives you 3,200 events per second, right? Such huge velocity of data, 3,200 clicks per second, this can be handled by using any NoSQL database. Your NoSQL can be used for real time. Can I update data in Hadoop? Okay, again, everyone says no. That's the right answer. I cannot update data. Okay, best part with NoSQL databases, you can update data also, right? So what your NoSQL databases support? They support real-time read. They support real-time writes. When I say real-time, this is fast. Okay, they support updates. All right. Now, when I'm talking about NoSQL databases, so now this topic is just related to HBase. But HBase is not the only one NoSQL database. There are lots of NoSQL databases available. Okay, for example, okay, now though there are lots of databases, NoSQL databases available, they are basically broken into categories. So you have different categories of a NoSQL database. Okay, for example, you have a column-oriented database. That's a category of NoSQL. You have document store database. You have graph database. So these are all NoSQL. All right. So there are lots of categories, and in every category there are lots of tools. For example, if I just talk about column oriented, your HBase is a column oriented database. It belongs to the column oriented category. There is one more database called as Apache Cassandra. If that's the most famous after HBase. Okay, so Cassandra also belongs to NoSQL category. Okay, Abhilash says Vertica. Yes, Vertica is also NoSQL. I am not sure about the category, but yeah, it is also NoSQL. Any other famous database which you have heard which belongs to NoSQL? Yes, there is DynamoDB. Okay, that's also NoSQL. Any others? There is one very famous NoSQL database. If I name it, yeah, it's MongoDB. Right? It's MongoDB. So MongoDB, it's also a NoSQL database, and the category which it belongs to, it's a document store. And when I say document, that is nothing but your JSON document. Right? So every NoSQL database belongs to a category. So if you want to see just example how many NoSQL databases are there, yes. So for example, if you consider key value stores, when I say key value, that's column oriented. So you have DynamoDB, right? You have Voldemort, which your LinkedIn uses. You have Citrus Leaf, Membase, React, okay, Tokyo Cabinet. So these are all your key value store. If you talk about big data clones, big table clones, sorry. Now what is big table? Does anyone know what is big table? It's actually mentioned here itself. So big table is actually the first NoSQL column-oriented database, and it was developed by Google. Right? It was developed by Google. Right? So your Apache Cassandra HBase is all clones of your big table. Okay, it has basically picked up the idea what your Google is doing, and they developed their own tools. Right? Then you have other category like document store. So you have Couch1, CouchDB, MongoDB, TerraStore, OrientDB. These are all document store. And when you talk about graph databases, so you have FlockDB, which your Twitter is using, and you have Neo4j, which is very famous. Neo4j is very famous in graph databases. Very simple to use. It's very famous. Right? So these are all your types, Okay, all your categories of your NoSQL database. So if you talk about speed and performance, so here this green one, so if you see this big table clones has the highest speed. It is highly scalable if you compare with other categories. And performance wise, key value stores are very fast, because what are key value stores? It's just like a map, right? It's very fast in reading and writing. Big table clones is somewhat close to that, okay, but performance is a bit slow. Okay, Minesh says, but all these database can read through Java or Python or Scala, right? Or can we use Hive? Good question, Minesh. So for example, these are not SQL, right? So there is no query language for accessing this big tables, this NoSQL databases. But the beauty is, see, we are into real world, right? We are into your Hadoop world, where every month there are 2-3 tools getting added, right? So yeah, people have identified that HBase is a good tool to use, but it does not support a query language. The next thing what they did, they developed a tool for that. Okay, so we have a tool available which you can integrate with HBase, and what that tool does, it gives you an SQL layer on top of your HBase, right? And that tool, it's not a part of the syllabus, but that tool is Apache Phoenix, right? Apache Phoenix. Okay, so what Phoenix does, it gives you a layer of SQL on top of your NoSQL database like HBase. Okay, now tell me, what is Hive? Hive is an SQL layer, right? Ultimately, Hive converts to MapReduce, but it is a layer. So what Hive team did is, Hive, they added functionality in Hive such that it can convert your SQL to other things also. So if you consider this way, if this is your Hive, it can only accept SQL. Up till the previous versions of Hive, it was only able to convert this to MapReduce. But the Hive team identified that this is a language layer. We can generate different languages from Hive also for SQL. So what they did, now Hive works with HBase also. Okay, so they have expanded the usage of Hive. It takes an SQL, it can convert to MapReduce also, it can convert to an HBase query also. Best part, which made Hive to go for a major version, it can convert to Spark queries also. It can convert to These queries also. Okay, so Hive has lots of uses. Yeah, so Minesh says, so it lets read the meta store. Yes. Okay, so everything combined with a single meta store. Right? I have one meta store here. Okay, so everything can access that particular meta store. Best thing is, if I create a table in Hive that is available to my HBase, to my MapReduce, to my Spark, to my These. That is meant by a same meta store. Okay, so you can integrate Hive with other tools also apart from MapReduce. This is all added in the latest versions of Hive. This was not available initially. That's why Hive went through a major release. When it added Spark, that was a very huge thing which they achieved. Okay. Rahul says metastore meaning. So Rahul, we discussed this in Hive, right? Hive stores your metadata inside a traditional database. It stores the schema in a database, the metadata in a database, and the actual data in your HDFS. That's a metastore. All right. Now, for whenever you will be dealing with NoSQL databases, This is the first thing you will come across, CAP theorem. All right. Now, what is this CAP theorem? So CAP is basically an abbreviation. Okay. Right. So A in CAP theorem, right? It stands for availability. Right. A, it stands for availability. P in CAP theorem stands for partitions. Right. When I say partitions, that means we are talking about distribution. Partitioning as in multiple machines. Right. C in CAP theorem, I just forget that. And let me check what is C. It just skipped my mind. Yeah, C stands for consistency. Right? Sorry, it just skipped my mind. C stands for consistency. Right? So whenever you will be dealing with any big data tool, these three. So what basically CAP theorem states is any tool which you would be using for NoSQL database, it can only have two of this CAP theorem properties. So basically, your database can be either be C or A, right? Or it can either be A or P, or it can either be C or P. Okay, that means your data can be either, it should lie between these three edges of your triangle. That's basically what CAP theorem states. Right? This was a huge research done in when this was developed. This new NoSQL databases was developed. All right. Now, if you talk about your HBase, now where your HBase stands? Okay, your HBase stands between C and P. Right. Now, why this? So why C? So your HBase, it is consistent. All right. Now, what do you mean by consistency? What do you mean by consistency? Okay, so Chaitanya says, is MySQL a NoSQL database? No, Chaitanya. But if you talk about MySQL, PostgreSQL, this is your actual traditional database. But if you talk about CAP theorem, they also have a place in CAP theorem. They stand in between A and C. Right? Now, what do you mean by consistency? Anyone, any idea what is consistency? It is basically your quality of data. Okay, the data which I am putting, when I retrieve the data, I should get the latest data available. Right? I should get the latest data available. Right? That is a consistent database. Right? Now, if you talk about Apache Cassandra, which is a huge competitor for your HBase. Now, if you see, Cassandra is not consistent. If you see, Cassandra is between available and partition, but it is not consistent. Right? I will just give you an example. What will happen if you use non-consistent databases? Let's say I have a website which is used for booking hotel rooms. Okay, I have a website which is used for booking hotel rooms. Now this website is very huge. Okay, it is a global website. You can imagine this website to be, let's say, Airbnb. Okay, if anyone knows about it, Airbnb. So this Airbnb can be accessed across the globe, right? Let's say I have a hotel which has only one room available. Okay, I have a server in US, I have a server in India for this particular website. when users log into both of these servers, both the users can see one room is available. But what will happen is, if I'm using a non-consistent database, okay, let's say this all information is stored in a database. If I book this room from US, this room is booked, all right? When I say the database is non-consistent, even if the person from India is looking at this room, he should see that the room is no more available, right? But he will see that the room is still available, though it is already booked. Okay, this is meant by non-consistent database. As soon as this room has been taken by this US guy, this India guy should see this room is not available. He sees it non-available, but that is not immediate, right? That is not immediately consistent, right? Over the period of time, your uh, India guy will see that this room is not available. Getting the problem, right? This such use cases usually happens in Cassandra. Right? Such cases usually happens in Cassandra. So if you're storing this particular hotel data inside a Cassandra database, if such cases occur, this database is not consistent. Right? It becomes consistent over a period of time. Right? Now HBase is consistent. If this problem if the data was getting stored in HBase, as soon as this guy books the room, this guy will see the room is not available, no more available, instantly. Okay, that is the beauty of your HBase consistency. Now, how do you think HBase can handle this? How do you what difference you see in HBase and Cassandra, which makes HBase a consistent database and Cassandra not? What do you think? What should be an probable thing which is missing in Cassandra? Any guesses will do. I know it's too early to ask this question, but any guesses? Okay, so Chaitanya says commit. Shiv Prasad says updating. Minesh says high availability. Not exactly high availability. All right, I'll tell you. This is basically, there's a difference in architecture in between your HBase and Cassandra. Okay, once I'll tell you this difference, okay, hopefully you will get the answer. So if you check HBase, HBase is a master slave architecture, just like your Hadoop. All right. In in Cassandra, there is no master. All are slaves. All right. So if I'm making an update in this particular machine, for this particular update to traverse across all the nodes, it takes some time. Okay, it takes some time to traverse this information across all the nodes. So let's say here was the US guy and here was the India guy. So US guy booked the room, but this information to go to your India server, this took some time. That's why your India person was still able to see that room available. Okay, such cases, this is basically called as it is eventually consistent. It is not immediately consistent. Now, if you talk about HBase, whatever reads and writes are happening, it's only and only through your master. So your master is up to date. Okay, your master, it is up to date. So as soon as I have my room available, India guy and US guy is connecting to the same server. That's your master. All right. So as soon as your US guy books the room, India guy will see the room is not available. So this is immediately consistent. Getting the difference? Okay. So your HBase is a highly consistent database. So this is what our CAP theorem states, right? Your single database cannot have all these three properties, right? It has to, see, ultimately, if you talk about Cassandra, Cassandra is also consistent. But the only thing is it is not immediately consistent. It is consistent over a period of time, eventually. Okay. But if you define a database, it can either lie on the edges of this triangle. It can only and only satisfy two of the properties of CAP. Right. So this is your CAP theorem. So HBase lies between consistent and partitioned. Right. HBase, if you see if you talk about availability, okay, the best part with HBase is, so see, HBase, though it is not available, when I talk about availability, so let's say if some machine goes down, your database is not available. That's called as availability. The best part with HBase is, it is not very available, but by adding a few other Hadoop tools, HBase is now made available also. So HBase is an exceptional case, right? HBase satisfies all the three things of your CAP, right? HBase satisfies all the three things of your CAP. So Minesh says, so whenever we try to book room, it gives 90 seconds hold. Is this the reason so it can sync with other instances? Exactly, Minesh. Right? So some websites, I mean, most of them usually uses Cassandra, right? So they usually have to recheck with the services to check if the room is available or not. This happens in case of flight bookings also. If you book a flight, it actually makes you wait. It pops up a message checking with the airlines about the availability. Though it was showing you available, but it still checks it when you're trying to book it. This is because it is trying to sync, right? Your Yahoo Mail also uses it. Your Yahoo Mail also uses Cassandra, right? So your Yahoo Mail also is eventually consistent. Okay, you must have seen this. Like if you delete a particular email, for those who are using Yahoo, if you delete a particular email and if you refresh your page, that email will again pop up, right? It will be getting deleted over a period of time. The reason is Yahoo uses Cassandra, which is eventually consistent. It is not immediately deleting it. Okay, so Minesh says, I heard Cassandra licenses are very expensive compared to others. Minesh, Cassandra is free. It's not licensed. It is a product of Apache. Okay, it is open source. Right? So Cassandra is Apache Cassandra. HBase is also Apache HBase. So both are free. It is just, see, ideally you can use Cassandra and HBase interchangeably. Okay. The things which Cassandra can solve, HBase can also solve. Okay, it's just you have to see this CAP theorem, that what is your requirement if you want it to be immediately consistent or eventually consistent. If you talk about available, your Cassandra is highly available, because if I talk about multiple slaves, even if your slaves are failing, it will still work, right? If I talk about multiple slaves in Cassandra, if your slave fails, this will store the data here. All right, so it is available. It can tolerate your hardware failures. It can tolerate your slave failures. All right, with HBase, okay, HBase can also tolerate this, but not directly. By using some additional tools, which is again your Hadoop tools, HBase is made available also. Okay, so HBase, if you talk just about HBase is consistent and partitioned. When I say partitioned, that's distributed, right? So HBase is consistent and partitioned. It is now made available by using another tool, and that tool which HBase uses, which makes HBase available, that is called as Zookeeper. Now what this Zookeeper does, now this Zookeeper is making your HBase available also. So if you use HBase with Zookeeper, your HBase is basically uh, it is following all your three abbreviations of your CAP theorem, right? If you're using Zookeeper and HBase, your database becomes consistent also, available also, partitioned also, right? Okay, so HBase, it is a NoSQL database which stores data in key value pair, and it is sparse, distributed, multidimensional, sorted map, and consistent, right? So we'll be talking about all of these things as it comes, right? Now, history of HBase. Now, just to tell you what is HBase, okay? Now, if you talk about HBase, so when you, let's say I create a table in HBase, okay? I create a table in HBase. Or to give you a better understanding, let's do one thing. Let's consider creation of table in a normal database, and then I will show you what happens with HBase. So let's say I have employee records. Okay, so Shiv Prasad says HBase means, is there any full form? No, Shiv Prasad. There's no full form for HBase. Okay, the tool is named as HBase only. Okay, now let's say I have some employee data which I need to store. Okay, this is my table. I have, let's say, employee ID. I have address. Then let's say I have bank account number. And let's say I have salary. Okay. Now, if this is your normal SQL database, see, if you consider NoSQL, the type of storage is very different. Okay, it is not traditional. Okay, it is not traditional. It is not relational. Okay, so once you get how HBase is managing this, HBase will become very simple. And just to tell you, if I share my experience, so I haven't worked on HBase a lot. Okay, so because our use case is not for NoSQL databases, we use structured data. I personally haven't worked on HBase a lot. I've worked a very little on HBase, but yeah, I know what other things in HBase theoretically. All right. Okay. Now, if I store, so this is my traditional database, right? I create a table. Let's say I name this as employee, and what I will be doing is I'll be inserting rows inside this table. Okay. Now let's say I want to store some other information inside the same table. Okay, I want to add a few columns. All right. Now it will become very difficult for me for addition of columns, right? If I add a new column, let's say I add one more column, let's say called as gender. Right? This table already contains 5 to 6 rows. If I add a new column, this new column would be empty, right? So I would be needing to go in and update these columns manually. Correct? Now let's consider what happens in HBase. Okay, let's see what happens in HBase. Now, if I want to store this 5 columns in an HBase table, so what I would be doing is I would be creating a table. I would be creating a primary key, right? A unique key in HBase. HBase only, so one thing with HBase, every table should have a primary key. When I say primary key, I'm not talking about relationships. So there is no relationship of a primary key and a foreign key. So don't take it that way. When I say primary key, every table should have a unique key, which is a unique identifier per row, right? Every table should have it. right? Otherwise, you cannot create an HBase table. So let's say I create a table ID. Okay, I create a table with a unique key, unique identifier for a single row as ID. Now, initially, I was defining 5 columns, right? In case of HBase, you don't need to define any column, right? You are defining something called as column family. Okay. Now, have you heard about this term column family? Anyone? What is a column family? Right. So Shiv Prasad says never. He has never heard. So I'll just define what is a column family. So this is usually typical way how your NoSQL database stores data. Column family is basically a category of column, right? Column family is a category of column. You define a column family for a table, and the columns you can add on the fly, right? So let's say I want a table which should contain 5 columns, right? I am not defining 5 columns at all. I just define one column as a column family, right? The columns which I'm be adding, I can add that columns on the fly. Right? Confused? Okay, let's look at an example. So I would just define a column family. Let's say employee, EMP. I define a column family, EMP. Right? This is not a column. This is a column family. Now let's say for employee 1, what information I have? Let's say I have employee name. So how do I specify EMP column family colon column name? That's my employee name. All right. I have employee address. So this employee address becomes my column, which belongs to the same column family EMP. Let's say I have his phone number. Okay, let's say for employee 1, I have these 3 information. Let's say I add one more employee, employee 2. Okay, now this is the best thing. So if you remember what we were talking about, this particular example, right? You would be creating multiple tables and multiple tables. Why? Because every table has a different schema. Now, how that is solved in HBase? You can put every data, all types of data, though the schema is different, in a single table. And how this is possible? So for employee ID 2, let's say I have employee name. Let's say I don't have the employee ID 2's address, so I will not add it. Let's say I just know his gender, EMP gender. Now what do you notice here? So for my employee ID 1, I have 3 columns: name, address, phone number. For my employee ID 2, I just have name and gender. If you notice, gender is a newly added column. It was not available in my employee ID 1. But the other columns like address and phone number, that is not available for my employee ID 2. Doing here, you are adding columns on the fly, right? So Minesh says, so it creates array kind of dynamically storage. Yes, right? Array, not exactly array, a JSON kind of a thing. It creates a JSON kind of a thing. So Rahul says XML, no, it's a JSON. Right? Key value pair. It's a key value store. Right? Let's say for employee ID 3, I don't have any of these. I have a totally new column. Let's say I have salary, EMP colon salary. Now this salary is not available for my employee ID 1, employee ID 2. This is how HBase stores data. right? So this is a difference between a normal database and a NoSQL database. This is column family concept is common across all your column store and key value store in your NoSQL database. This is same in your Cassandra also. Okay, let's say I have some more information about this employees. Let's say I have bank details also. So what I can do is I can create one more column family as bank details. Right? So a single row, a single ID can be associated with multiple column families. And within a column family, I can have any number of columns. Let's say for employee ID 1, I have 3 columns. For employee ID 2, let's say I have 1,000 columns. Doesn't matter. It will accept. For employee ID 2, I have only a single column. Doesn't matter. Okay. So this is a variable schema kind of a thing. Right? Variable schema. Just for entering data, you should have the column family. You are not at all defining column names. You define column names on the fly. Okay, this is what a NoSQL database is. Now, ultimately, when this is getting stored in your edge base, what is this? This is just like a hash map. Yeah, yeah. Thank you, Manish. So Manish is nice explanation. Okay. All right. Now, if when it is getting stored in your edge base database, all right, it is stored as a map. Right? Now let's say I have, now this is, I have just shown 3 employees. Let's say in this table, I have 5 million employees, huge number of employees. Now the size of the table would be very huge. Can a single machine store this entire 5 million records? It's very difficult, right? A single machine storing this entire 5 million records, this is a very huge data for a single machine. So that's the reason HBase works as a cluster. Right? HBase works as a master and slave. It has multiple slaves. What your HBase will do, it will break this entire huge table which contains 5 million records into multiple pieces. And each piece, so if I just show you schematically, this is my entire huge table from 1 record to 5 million records. Right? It will break this entire huge table. Let's say in our case, for example, let's consider it is broken into 5 pieces. Right? From 1 to 1 million, from 1 million 1 to 2 million, from 2 million 1 to 3 million, from 3 million 1 to 4 million, and from 4 million 1 to 5 million. Let's say it breaks your entire table into these 5 pieces. Every piece is stored on a separate machine. Every piece is stored on a separate machine. Now, when I say this piece in terms of HBase, these are called as regions. Okay, these are called as region. So this entire one huge big table has 5 regions. And these are stored on separate machines. The machines where it is stored, it's nothing but your slave machines. Your HBase is a master slave. Slave machine is the place where this region would be stored. That's the reason your slave machines in HBase is called as region server. So what your region server stores? Your region server stores multiple regions. This multiple regions can be of a same table or can be of different tables, doesn't matter. Ideally, a single region server can store up to 1,000 regions. Right? A single region server can store up to 1,000 regions. Getting a flow of HBase, what it is. and I can have multiple regions. Okay, I can have multiple regions but HBase has a master slave pattern. So HBase has a master which basically manages all these regions. That is called as an HBase master, H master. Okay, H master. Okay. Now when I talk about this table, this is just like a map, right? This is just storing data like a map. So ideally, if you talk in layman terms, what are you doing? You're breaking a map into multiple chunks, and a same map is stored across multiple machines. Correct? Am I sounding right? A single huge map, hash map, it is broken into multiple parts and stored across multiple machines. It's a single hash map. Hash map or a hash table you can consider, if you talk in terms of Java. Correct? Any doubts in this statement? Okay. Now tell me, okay, programming experts, a question for you. Can I have a single hash table or a hash map of Java? Okay, so Chaitanya says me to repeat. Okay. So first I'll repeat this and ask this question. So HBase table is a huge hash map, a Java hash map or a Java hash table you can say, which is broken into multiple chunks and stored across multiple machines. Right? So HBase table is a huge single hash table, hash map, which is broken into multiple chunks and stored across machines. Right? Got it, Chaitanya? Yes. So tell me, in Java, can I break a single hash map and store across machines? Is it possible in Java? By the way, HBase is also written in Java. Right? HBase is also implemented in Java. Okay. So Minesh says no. Rahul also says no. So it is not possible. Okay. So this is what is basically history of HBase. So if you look at HBase history, initially, okay, HBase is inspired from Bigtable, right? Your Google Bigtable, right? HBase is inspired from your Google Bigtable, okay? Now, initially, this concept, okay, initially this Bigtable was a concept because I cannot have a single hash map broken into multiple chunks and stored across machines, okay? What Google did, Google issued multiple research papers, okay, in which they tried to build a single hash map, break it, store it across machines. All right, there were lots of researches on this, okay, but somehow Google was not able to implement such hash map because it is very difficult. If a single machine fails, a part of my hash map has gone. That means the entire hash map is gone. I cannot access my hash map. Now what happened is in around 2006, what was the thing which happened? Around 2006, what was a unique thing which happened? We got Hadoop, right? Hadoop was developed in 2006. Now Hadoop, it is actually managing your data across multiple machines. It is a distributed file system, right? Now with the innovation of Hadoop, Google, what they did is instead of creating a distributed hash map, they used Hadoop's file system for creating a distributed hash map. And with this, they were able to use Hadoop's distributed file system, and they were now able to implement Bigtable. Right? So until Hadoop was developed, This concept of big table was just a concept. It was no real implementation. It was just on paper. Since 2006 onwards, when Hadoop was developed, that was the time when HBase got a startup, or your big table got a startup, right? So big table was developed in 2006 after Hadoop, which used Hadoop. And why Hadoop? Because it wanted to break the single table in a distributed manner, right? So big table, which was just an concept, it went to your Hadoop in 2007. In 2008, it became a Hadoop's sub-project. So HBase was developed in 2008, okay, when it came under Hadoop. That's why it is, as HBase is using your HDFS, it is coming under your HBase Hadoop's umbrella. Okay, that's why HBase is a Hadoop ecosystem tool. Right? In 2010, HBase got integrated with Apache. It became open source. And 2011 was the first stable release of HBase. So if you see, HBase is not very old. Okay, it's a pretty new framework, right? See, initially, I mean, in the old days when Oracle was developed, if you talk about Oracle version 1, okay, Oracle also didn't support a lot of SQL, right? Oracle had issues in subquery. It did not support subqueries. It did not support complicated joins. But now if you talk about latest Oracle versions, it supports everything. You name it, they have it, right? Similarly, HBase is now relatively very new. That's why it does not support a lot of things, right? But in coming few years, HBase would be a top-end tool for your usage. It will support everything. That's the vision of HBase, right? Now, if you compare HBase with RDBMS, HBase is column-oriented because you define columns, and most of the RDBMS is row-oriented. HBase has flexible schemas. You can add columns on the fly. RDBMS has fixed schemas. HBase is good with sparse tables, right? When I mean sparse, huge tables. Okay, RDBMS are not optimized for sparse tables. Okay, HBase can use MapReduce, right? HBase can join for MapReduce, and it is optimized for joins, RDBMS, right? HBase joins are not optimized. Okay, HBase has tight integration with MapReduce, and RDBMS, it's not applicable at all. RDBMS does not has MapReduce. Okay, so Minesh says, I think next 4 years, even all RDBMS database will behave like these. Yes, right? So it's a different way of thinking now, right? Now all your RDBMS will ultimately turn up the NoSQL route, right? One of a typical use case is Redshift or Teradata. I think they would be the first one to go to NoSQL. Yeah. Okay. HBase are horizontally scalable. Okay, so when I was talking about the architecture, if you feel the region servers are less, I have lots of data, you can simply add more machines. You can add more region servers. It will automatically balance data, just like your normal data node, HDFS data node. In RDBMS, you have to shard the machine. When I say shard, you have to see, you can make a RDBMS also distributed. That's called as sharding. I can scale up my RDBMS using multiple machines, but that is very difficult to do. All right, and it is not fault tolerant. Okay, if one of my machine fails, my entire RDBMS fails. It's very difficult for your administrators. In case of HBase or Hadoop, if you talk about, if any of your data node or slave is failing, it will automatically work. You don't require any administrative task to handle the situation. If one of your region server fails in HBase, data is still available. Ultimately, how this is possible? So when I say HBase uses HDFS for storage, this also means So if I talk about your HBase architecture, so this is your HBase master. And when I talk about region server is hosting your actual HBase data. This also means region server should run a data node, right? Every region server should have a data node. Everyone agrees? Because region server is the one who is storing data. For storage, it is using your HDFS, and HDFS stores data on your data node. So this can be your name node. This is your HBase architecture, right? The only thing missing here is HBase now, the latest versions of HBase, it cannot work without Zookeeper. I'll discuss what is Zookeeper later. So you have one more entity, Zookeeper. Right? So without Zookeeper, HBase won't work. Right? We'll discuss the architecture about Zookeeper in the coming slides. Any doubts in this? Why region server should have a data node? Because actual storage is happening on your region server. Yes, so Minesh says we have pig and elephant, so definitely we need Zookeeper. Yes. Right. It is good for semi-structured data as well as structured data, and RDBMS is only good for structured data. When to use HBase? When your data is unstructured, you require high scalability, versioning of data, generating data from a MapReduce code, column-oriented, and high volume. This is when you should use HBase. Right? When not to use HBase? When you have very less data, you should not go for HBase. Okay? It lacks RDBMS commands. You don't have queries. Right? You cannot, if I create a table in HBase, I cannot say select star from this table. There is no query such like that. Okay, so it lacks a language layer. Okay, HBase is an excellent tool. The only thing missing in HBase is it does not have a query language. In the coming years, if HBase gives you a query language, it will become a very top-end tool to use. Okay. See, there is no use, right? If I have a very excellent tool, but my users cannot interact with that tool, it's very difficult, right? If I'm not able to interact with a specific tool, I would prefer not using that tool. Okay, that's why HBase is not used much, because it does not have a layer of query. Though other tools are giving you query language layer, like you can integrate HBase with Hive, with Phoenix, but there is still some additional steps you are requiring, right? You have to install Phoenix. You have to configure Hive to use HBase. So there are some additional steps involved. That's why very few people uses HBase. Okay. Why do you think Cassandra is more famous? Cassandra gives you CQL. Okay. Cassandra has a Cassandra query language. Right. So Cassandra gives you a NoSQL query language also. That's why Cassandra is preferred more over HBase. Okay. And when you have less hardware, you should not use HBase, right? One more thing, HBase, it can run on a single machine also. It can run on your laptop also, but this should be only for development, right? You cannot use a single machine HBase for a real production use, right? Okay, so this is a use case where your HBase is used. So you know a Facebook Messenger, right? A Facebook messaging system, that is HBase, right? Your Facebook manages all your messages. Now it is so when you send a message to a specific person, right? It is delivered to him real time. Correct? So this is because of HBase. So it is column oriented, distributed, robust, scalable, open source, key value, linearly scalable, real time. Okay. So Facebook had two use cases, two types of data patterns: a short set of temporary data that tends to be volatile, and an ever-growing set of data that rarely gets accessed. Okay, so they store. So Facebook uses Hadoop. Okay, we definitely know it, right? Because Facebook developed Hive. Okay, so this functionality of Hive integrating with HBase, this is also developed by Facebook. Right? You can integrate Hive and HBase. This is also a functionality developed by Facebook. Right. So everyone has heard about UID, right? Your Aadhaar card. Yes. So Aadhaar card, this entire system, which was initially built by Infosys, right? Aadhaar card is built on HBase, right? Your entire UID data, it is stored in your HBase. Now let me tell you where you should use HBase. You should use HBase only for reading and writing. Yes, it is a very big implementation in the world. Yes. Just an additional info, this UID project, it is not running on your Apache cluster or your Cloudera cluster. They're using MapR, right? MapR is also a distribution of Hadoop. So MapR cluster with HBase. This is what your UID project is. Okay. Now you should use HBase only for read and write. If you want real-time read and write, only then you should use HBase. If I have a use case where I want to process my entire data, let's say I have a huge employee table in HBase, I want to, let's say, do some processing on my entire data, like how many males are there, how many females are there, how many has, uh, like how many employees are there between this and this age. If I want to do such kind of processing, you should never use HBase. If you want to do processing on your entire data set, never go for HBase. How will you process this entire data? You should always prefer MapReduce for this. Where you want to process the entire data, always prefer MapReduce. When I say MapReduce, Hive, Pig, these kind of tools, or Java. HBase should be used only when you want to read or write real time. It is just to store and fetch fast. Only then you should use HBase. Now in UID project, what we do, how it is designed basically. So when you create a UID, you are giving your unique IDs, right? You are giving your retina scan, you are giving your fingerprint scan. All right. So whenever you basically, if you go to an UID center, if you just give your fingerprint scan, immediately it will tell you that this is your information. Immediately when you give your thumb impression, it will fetch the entire data. It will say that this thumb impression belongs to a person XYZ. This is the address. This is every information. Correct? It is very fast. You just give your scan, immediately it will give you data. Why? Because this is fetching data from HBase. HBase is really fast in fetching data. Right? You're not processing anything if you're fetching data, right? So for processing, you should never use HBase. It is just used for reading, writing. Okay, so these are some more implementations of HBase. Your Yahoo uses HBase, Facebook, Twitter, all of these uses HBase. Now the architecture, right? So as I just mentioned, your HBase, it has a master called as HMaster. It has slaves called as region servers, right? And definitely you have clients, which is reading and writing data. Right? We would be coming to this components in the coming sections. Okay. Now very important. Okay, let's do one thing. Let's take a 10-minute break before discussing this concept, how HBase stores data. how HBase distributes data. This is very interesting and requires a fresh mind. Let's take a 10-minute break. All right, so I'll just set up a timer. All right, guys, see you guys in 10 minutes. Yes, guys. So let's get started. So everyone, I hope everyone is back. All right. So let's consider. Okay. So we are talking about how HBase distributes data, how HBase manages this huge volumes of data, and with this huge volumes, how does it manage real-time reads and writes? All right. Now you can imagine, right? So we are talking about gigabytes, terabytes, and petabytes of data. With such huge volumes of data, still HBase is giving you real-time read-write. Imagine how powerful HBase is. Okay, now how it is able to do it? Let's discuss that. So let's consider a table. Let's consider a table employee. Now the only thing required to define a HBase table is you have to define a row key, that's your ID basically. I'll name it as ID only. And you have to define a column family. In fact, you don't need to define an ID also because you would be putting it on the fly. Okay, you just have to define a column family. Okay, let's say I define a column family as EMP. Okay, for inserting data. Now remember, for your edge-based tables, the ID which you would be using, this ID can be anything. The only thing is it should be unique. Ideally, the data type of ID is byte array. Okay, one additional thing in HBase, there is no concept of schema, right? So there is no concept of your data types in HBase. Okay, there is no string, no int, no float, no double, anything, nothing, right? Everything is byte. Okay, so when you insert data, you have to specify a unique ID. Now this unique ID can be an integer, can be a float, can be a long, can be any Java object, it can be a string, anything. Anything can serve as your row ID. So let's say I insert the first employee, I give the ID as 1, I put the data name, and this name is, let's say, my name. I insert a second row with only address, and let's say India. Similarly, let's say I store huge number of rows. Let's say I insert 1 lakh rows. What HBase does, so this table initially it's a fresh table, right? So when you load data, everything is getting loaded against a single machine, a single region, because it's a, so when you create a table, the table is empty. So once you start loading data inside this table, over the period of time, this data, this table will grow and grow and grow. Okay. Once it reaches a configurable limit, right? Once the table data, it reaches a configurable limit, the table is broken into regions, right? The table is broken into regions. So let's say for my case, just an example, let's consider the limit is, ideally the limit should be in size. Okay, the default limit is 256 MB. Okay, let's consider at 50,000. My table data broke into two regions. Okay, this first upper part would be stored in region 1. This will be region 1 basically. This lower part would be region 2. each region would be stored by a different region server. It may be different, it may be same, anyhow. Okay. Now, how does HBase makes it real-time read writes? Okay, so what HBase does, now listen to this very carefully. Whenever you insert data to HBase, okay, whenever you insert data to HBase sorts your data. HBase sorts your data on the basis of the keys. Now, which key? Basically the row ID. Right? HBase will always sort your row ID. Now, why sorting is required? Why HBase sorts data? So you can say HBase is a sorted hash map. Okay. Now, why sorting is required? So let's say I put data in any order. Let's say I insert employee ID 1 first, then employee ID 20,000, then employee ID, let's say 35,000. Okay. Then employee ID 3. Okay. Then employee ID, let's say 60. So I insert in any order. Okay, what HBase will do, when we insert this data, HBase will automatically sort this. So let's say in any order, ultimately I insert 1 lakh employees. Ultimately, HBase will store this in sequence 1 to 1 lakh. Now, why HBase does this? This is for managing data. So let's say my region broke into 2 regions. My entire table broke into 2 regions. This first region, my HBase knows that the first region start key is 1, end key is 50,000. My second region's start key is 50,001 and the end key is 1 lakh. Alright, so what HBase does, when it breaks into regions, for every region it knows what is the starting and the ending key. Alright, so it will create 2 regions. This is for 1 to 50,000. Another region 50,001 to 1 lakh. Okay, any doubts still here? Now it is still not clear why it is sorting it. I'll tell you why it is sorting. Okay. Now what HBase does, HBase maintains some catalog tables, right? There is a system table in HBase. Same like you have in MySQL or Oracle, right? There are some system tables. HBase maintains 2 system tables. Up till now, in the latest version, this is only 1 system table. So let's not get there. It maintains 2 system tables, meta and root. To be specific, it is dot meta dot hyphen root hyphen. This is the table name. Now what it does, when it breaks this table into 2 regions, in meta table, it will store that my region 1 for this table contains rows from 1 to 50K. My region 2 for this table contains rows from 50K1, that is 50,001 to 100K. Now what is the advantage of sorting? Let's say I want to read a data, and let's say I want to read the row 60,000. If it was Hive, what Hive will do? Hive will go through this entire 1 lakh rows, correct? To get the row 60,000 if I use a where clause. Now what HBase does, HBase will first go to this, my client will first go to this meta table, right? It will not directly go. I have a zookeeper in between, but let's forget zookeeper for now. Okay, your client will go to this meta table. Based on this ID, your client can simply identify, right, that this particular 60,000 row will belong to which region. And why it is simple for a client to identify? Because my regions are sorted. It will definitely know that the 60,000 would lie in region 2. Right? Yes, Chaitanya. It is sorted. That's why your client knows that the 60,000 row will lie in the region 2. What your client will do, it will directly go to this region 2, read the data, fetch it, give the output. It will never ever go to this region 1. Now the 60,000 row, it may be there in region 2 or may not be there, right? I can have some rows missing. But if it finds it, that's okay. If it does not find it, it will still not go to other regions. So imagine how small scan it is doing. My table can be very huge, but it is doing a very small table scan. That's why HBase can manage real-time read-writes. Similarly, let's say I want to write this data. The 60,000 row, I'm not reading it. I want to write this. Your same sequence, your HBase goes to meta table, client goes to meta table, checks which region this particular row should belong to. It will identify it belongs to region 2. It will directly go to this region 2 machine, make an entry of 68,000. That's it. This makes HBase real-time reads and writes. That's why it's possible for real-time read writes. Any doubts in this operation? Now there are more things involved. We haven't gone to great details. There are more things involved. Now there can be questions like what happens if while writing it, this region server fails. Ultimately, it's a hardware. It can fail. Right now, let's go to that particular details. Yeah, so Abhilash says, is there replication since data is split? Yes, Abhilash. So we are getting into that detail. See, ultimately this data is stored on your HDFS. Okay, this region server is storing data on your data nodes. Whatever thing goes to your HDFS, it is always replicated. Right? So this data is replicated. So even if this machine goes down, my data is still available. So let's see how your HBase manages that. Okay. So let's say in a table, let's say employee, I have one column family, let's say CF1, for example. For every column family, HBase architecture gives you some things. The first thing which your HBase architecture gives you is called as WAL, wall. Now this wall, it actually stands for write ahead log. It stands for write ahead log. What happens is whenever you write to this particular, it is for every column family. When you write to a specific column family, this entry is first made to your write ahead log. Now remember I told you the data is sorted in HBase. Can I sort any data which is there on my disk? What is the first prerequisite for sorting data? The first prerequisite is data should be in memory. I cannot sort data which is there on my hard disk, correct? I need to take that data to my RAM, either in any data structure, for example, a list, an array, or a map for sorting it. Data structures are always stored in RAM. All right, I cannot sort the data which is there on my disk. So what your HBase does, HBase stores this to WAL, write ahead log. This is a file, and this file is there in your HDFS. From this WAL, it goes to memory, and that memory is called as memstore. Okay, this is the place where your HBase sorts your data, because sorting you require memory. As soon as my data is sorted, it immediately writes this data to my final HBase file, and that file is called as H file. Okay, so the ultimate thing which is written to your HDFS, which contains your live data, real data, that's your H file. This H file is created, this wall is emptied. Okay, the write-ahead log is cleared. Right, getting this point. Any doubts in this? Yes or no? Anyone? Any doubt? Great. Now, over the period of time, I would be writing a lot of data inside this column family for this particular table. Okay, for multiple files, I mean, whenever it writes to wall file, then it goes to memstore, then goes to your HDFS. So there could be multiple H files created per region server for a single column family region, right? There could be multiple H files created. Over the period of time, these H files are merged together into one huge H file. That's again a concept in HBase called as compaction, which is there in the coming slides. Right? So this is the reason your HBase data is sorted. Yeah, because it can identify, see this is sorting, it can identify that my first region belongs from which row to which row. Second region starts and ends at which row to which row. Right? That's why this ID is necessary in your HBase. Okay, so you have a HBase master. Whenever we write file to your HBase, it writes to a wall file, which goes to your mem store and ultimately to your H file. Now this H file and wall file, both are there in HDFS. Right? We are yet to discuss about Zookeeper, which we'll park for now. We'll discuss that later. Is components, table which is made up of region. A region, it is a range of rows stored together. That's why HBase is called as a column oriented. Right? Basically, it's not column oriented. You can say it's a column family oriented database because all the column families belonging to a same table are stored together on your HDFS. That's why it is a column oriented database. What are region servers? It serves one or more regions. And what is a region? A region is served by only one region server. We know about a region, right? It's a component of your table. It's a part of your table. So region server stores this regions. Okay, a single region is served by a single region server. I cannot have a region stored at multiple region servers. It would be replicated in HDFS, but it would be live present in a single region server. Master is responsible for managing the cluster. HBase stores its data into HDFS. Okay, it relies on your HDFS high availability and fault tolerance, which makes your HBase available. Remember the CAP theorem, right? Okay, so Rahul has a question, what happens in case of append? So append is nothing but write, correct? Rahul, you're writing it, right? See, ultimately, whenever my data is there in my HBase, ultimately it goes to memstore first. Okay, in memstore, I don't have a limitation of updating a file or not updating a file in HDFS. From memstore, it directly dumps data to H file. So appends are also possible, writes are also possible, updates are also possible in HBase. Okay, so Rahul says, if my row 1 is full and passing data which should come in row 1. Okay, so Rahul, sorry, if my region 1 is full and passing data which should come in region 1. This will never happen, Rahul. Okay, if your meta table will store whatever regions are stored by your region server. So if your region is broken further, Okay, let's say my region server is full. Okay, let's say I have multiple machines, or let's say I have a single node machine. I have one region server, and this region server is now full. Okay, so Rahul says like I have ID 2 to 10 in region 1 and append ID 1. Yes. Okay, let's say this region server contains one use region, for example. Okay, from 1 to, let's say, 1 billion. It's a use region. If I add one more row anywhere in between, let's say I'm adding the row 5. Now this may cause my region to blow up, my region to break. Okay, so when this happens, your region would be divided into two equally sized region. It will never happen that 1 to 1 billion year and only 1 year. This will never happen. Okay, my regions, when they split, they tend to split in equal size. So my region would split in 1 to 50 million and 50 million 1 to 1 billion. When they split, these two can go to separate servers. When they go to separate servers, they inform your HBase master that we have split into these two daughter regions, and HMaster, that your HBase master, will likewise update the metadata tables, that your meta tables, system tables. Okay, so Shiv Prasad says regions are machines. No, Shiv Prasad, the regions are basically part of your table, and that part is stored onto a machine that is called as a region server. So region servers are machine which stores region, and region is a part of your table. Okay, so region is a range of rows stored together, and region servers stores these regions. Okay, a single region server can store multiple regions. It can be of a same table or from multiple tables. Okay, so what happens is, in this architecture, so we have discussed about the wall file, write ahead log. We have discussed about the memstore. We have discussed about h file. Now there's one more thing. This is a region server, and this is entire thing managed for your one column family of a table. This is true for every column family. Every column family of a table has a memstore, a different memstore. Every column family has a different wall file. Okay. Now what happens in case of read? When your client reads data, your HBase also has a concept of block cache. What happens in block cache is, whenever it reads data, ultimately it's reading from your H file. Whenever it reads data, it reads from H file, brings it to block cache, and clients read it from the cache. Why this piece is introduced? Let's say my same client wants to read the same data again. So what happens is, instead of going to the cache, the actual file, it will read it from the cache. Cache is always stored in memory. Right? So once my client reads data, that would be slow. The first time it would be slow comparatively. From next time onwards, my data read speed would be very fast. The reason is, most recently read data is stored in the cache. Right? So that's one unique thing. This is introduced for optimization. All your recently read data resides in the cache. So a client does not actually goes to the H file again and again, because H file is stored on disk, right? So it brings everything to cache, reads from the cache from the next onwards. Okay, so Minesh says how much data it stores though in the cache, right? So it stores very less data, Minesh. It's around 64 KB. So if your client is reading huge data, the previous data which is already there in the cache, that is removed. Okay, so it's like a cyclic thing. Most recent data is there in the memory, old data is, it keeps on flushing out. You can configure the size of the cache. Okay, so Rahul says on update, it will handle cache automatically or we have to. It will handle automatically, Rahul. We don't have to do anything specifically in HBase. It will, everything is handled automatically. Okay, so this is overall architecture. Right, you have an HBase master. Zookeeper we are yet to discuss. Okay, this H log is nothing but your wall file. You have a H file and a mem store per region, per column family. Sorry, per column family. On a single region, I can have multiple mem stores and H files. Okay, this is per column family. Ultimately, when it dumps data, it stores to your HDFS. For writing it to HDFS, just an additional thing, for writing it to HDFS, it uses the Java API to write. Your Hadoop gives you a Java API for writing to HDFS. It uses the same. Right. So you have HBase master, you require name. So I had drawn this earlier. HBase and your region servers, all your region servers should have your data node running. Zookeeper, we have parked it for now. All right. So it is built on top of HDFS, stores key value pairs in column formats, column fashion. Columns are clubbed together as column families, provides low latency access to small amount of data within a large data set. HBase is used for real-time needs. Okay, that's we have discussed. This thing also we have discussed. All right, clients don't interact directly with the underlying H files. It directly first when it writes to a wall file which goes to memstore, and then through your H file. Okay, default size of H file is 64 KB, which is configurable. For reading, okay, when I read it, it first reads from the cache file. If it's not there in the cache file, it may be there in the memstore also, right? Because let's say I write data, immediately I'm trying to read the data. Okay, so when I write data, it may be possible that the data is still not gone to the H file yet. It is still there in the wall or the mem store. Okay, so first your client tries to read the cache file. If it finds the data there, that's okay. If it does not find, it goes to the mem store. If it does not find the data in the mem store also, then it goes to the H file. Right, so the first two read operations are basically memory operations. Block cache is also memory, mem store is also memory. Okay, so over the period of time, this will become fast and fast. And this everything, wall file, mem store, block cache, H file, everything is for a single column family. If my table has 10 column families, this structure would be repeated 10 times. Okay, HBase region is 256 MB by default, which is configurable. A region can contain multiple column families. Let's say this is the column family 1, let's say personal, okay, and a column family 2, let's say address. So how can I, so let's say this entire table is my employee table. Okay, I can have a column family called as personal. So I can add columns like name, phone number, then I can add email address, gender, age, all the personal information I can store in the first column family personal. In the second column family address, I can store information like your street name, building number, flat number, address line 1, address line 2, okay, state, city, zip code, all of these columns I can store in the address column family. And for every column family, I have a wall file, memstore, block cache, and multiple H files. Right? Any doubts in this? Great. Okay, so Minesh says, so we are sorting based on frequent access. No, Minesh, as soon as data is entered into HBase, it is sorted in the mem store itself. It does not depend if you don't access the data, still the data is sorted. Because based on the sorting only, I can determine the starting and ending keys of my region. All right, so it's every time sorted. If you access or don't access, data is always sorted. So if you look at this, if I have multiple H files, each H file is sorted. So it may be possible that my H file 1 is sorted, H file 2 is sorted, H file 3 is sorted, but when I club them together, the sorting no more remains, right? So that is a concept called as compaction. So when you do compaction, so it will do a sort merge. Okay, so when it will merge together, it will do a overall sort again. All right. Yeah. So the HBase HMaster is responsible to assign regions to each region server when you start HBase. Right. This also has two special tables, root, that is -root- and .meta. Okay, so these are the system tables. So what root contains? So basically, I'll tell you how is my write happening. How is my read or write happening? So when I want to read some data, okay, when I want to read some data from HBase, so I'm introducing the term now. I won't go into the details for now. Clients connect to Zookeeper. Okay, Zookeeper contains the address of root table. Okay, so basically Zookeeper will redirect the client to the root table. Based on what, so what root contains? Root contains the address of meta table. So basically this is, if this is a meta table basically, so I can have this region 1 stored in, let's say, this IP, this host name, or you can say this IP1. This region 2 is stored on this host name 2. Okay, so this is my meta, how my meta is stored. So let's say I want to read a particular column family, and my column which the row which I'm trying to read is, let's say, 10. So it goes to root, right? Root will redirect it to which meta you need to use. So let's say 10 lies in this particular region too. So it will redirect my client to this meta. From meta, it will get which machine to connect to. It will go and connect to that machine. This machine is basically a region server. Now the best part here is, this is all happening for a single client. The best part here is, so for a client to read data, it is going three ways. First to Zookeeper, then to root, then to meta, and then finally to your data. This path, basically, your client can cache. This path, your client can cache. Okay, so first time, client will go this entire path. Second time onwards, your client already knows that this particular row, which I am trying to read now, belongs to which region. It will directly go to your region server. Okay, so over the period of time, your reads would be very fast. Okay, because all the recent information is cached. Inside this region server also, my recent information is cached inside your block cache. So block cache is here. Your client also has a cache. Okay, and what this client cache contains? Where is the root? Where is the meta? Where is my region server? It keeps on caching the information as it traverses everything. Right? Okay, so we haven't went into Zookeeper yet, right? So I'm repeating this again. Okay, so this is what I was discussing. What happens when a client interacts with an HBase cluster? So it first goes to root, from root to which meta, and from meta to which region server. Now compactions. Now what happens in compaction is, so as I discussed, for a particular column family, I can have multiple H files created of 64 KB. Now HBase has two types of compactions. Okay, in the first type, that's called as a minor compaction, HBase will pick up these files and create new files which are less in number. Okay, so let's say if I have 100 H files, in minor compaction, this would be merged, and it can be any number. It can be merged to 10, or let's say it can be merged to 50 or something. So my 100 H files is now coming up to, let's say, 50. So basically it is reducing the number of H files. It is not reducing your data. It is reducing the number of cache files, H files. This is called as minor compactions. Right? This is called as minor compactions. Now which files to merge and which files not to merge, that your HBase itself chooses. Okay, that's random, which your HBase does. We cannot control. Okay, so in minor compactions, all your H files is merged together into a smaller number of H files. That is minor compactions. Okay, what is a major compaction? That's a different type of compaction. In major compaction, this 100 H files would be merged to a one big H file. That's a major compaction, right? So major compaction, it does not happen frequently because it requires a lot of I/O, disk I/O, right? So major compactions does not happen very frequently, but it should happen because over the period of time, this is meant for optimization. So instead of referring to multiple small files together, if I read a one big huge single file, my read would be fast, my read would be better. Okay, so over the period of time, your HBase does compactions. All right, now the best part, one more thing your HBase does. Your HBase does versioning of data. HBase does versioning of data. Okay, so Shiv Prasad says, what is the file size for minor and major compactions? So Shiv Prasad, the file size can be anything. Okay, for minor compactions, like, see, if I have 100 H files, your HBase can choose all the 100 to do a minor compaction or only the first 50 to do a minor compaction. It can be anything random. Okay, and if it does a major compaction, it will definitely merge all the 100 to one huge H file. Okay, and coming to the size for that, so that's what I was coming to. Your HBase data is versioned. All right, so when it creates a major compaction, it will delete all the versions also. It will delete duplicate data. It will delete versions. Okay, so so we cannot say what the size would be, but it would be huge. Right? It would be used in your single H file. Okay. Now see, when you insert data to a table, let's say these are my row and columns. Yeah, no size limit. Okay, no size limit. Okay, so when you insert data, so let's say I'm inserting data, I'm inserting a row here, here. This is my one row. This is my one row. Okay. Now what are these? Where your intersection of your columns and rows are happening. These are called as cells. Correct? So this is cell 1, cell 2, cell 3 for a single row. Correct? Now whenever you insert data, these cells in your HBase are by default versioned. And the default version it uses, it is timestamp. So let's say I insert a data to my HBase My row ID is 1 and my data is, let's say employee is my column family, name is my column, data is Hardeep. For the same ID, I'm inserting a same column. I have changed my name. Will it, tell me one thing, will it create two duplicate rows with the same row ID or no? Will it allow? Will it allow this operation? Right, so everyone says no. Okay, that's a wrong answer. Remember I told you HBase allows updates. Okay, so this is possible, I'm updating. Okay, now when I say HBase allows updates, ultimately HBase is storing my data in H files. Where my H files are stored? In HDFS, right? Does my HDFS allows updates? No. So what your HBase does, how your HBase manages this is, HBase will, you will get a feeling HBase has done updation, but internally it is not updating it. What it does is, it maintains a version for this, it maintains a version for this. Ultimately, you will get a feeling that my data is updated. This is my latest data. Okay, but this is still there in your HBase because ultimately it's H file. H file is there on HDFS. I cannot update in HDFS. So this information would be there, but with an old timestamp. This information would be having a latest timestamp. Okay, so if you select from this table, it will show you this, the latest one. Old one, it will never show you. This is how HBase is managing updates. It does not touches the old data. Old data is still there as it is. It just updates the version. Getting it? And what happens in compaction is, when it does a major compaction, then it will remove all of these previous versions. Okay. So getting the advantage of doing compaction. Okay, major compaction. It removes the previous versions also, ultimately decreasing your file lookup size. Right. Okay, so this is simple. HBase can run in local mode, that's on your normal laptop, without installing Hadoop. Still you can use HBase. It can run on pseudo distributed mode, just like Hadoop, on a single node Hadoop cluster. Or it can run on a fully distributed mode. That's your actual multi-node cluster. Right, your HBase comes with a web UI. You have a UI for your master and a UI for your region. So you can check how many regions are hosted by my region server. How many region servers I have. Okay, you can see all of such informations in your UI. This is how your UI looks like. This is your master UI, where you can see how many servers are there, region servers are there. And this is your slave UI, in which, okay, slave UI is not there, but in slave UI, you will see how many regions that region server is hosting. Okay, request per second. You can count the number of events, right? All of these are possible from the UI. HBase is very fast. If your cluster is huge, HBase can handle more than 3000 events per second. HBase is very fast. That's why we say it's real time. Okay. Now this is how you access HBase. So you have a UI tool, sorry, a shell command based access, just like Hive or Pig. If you're using Apache HBase, Apache distribution, you don't have any UI for coding. You don't have any UI for writing your queries or something, right? You just have shell. Okay, so we'll be looking at an example of this. Okay, so these are all your shell commands, all right. So guys, for tomorrow's session, we have actually discussed whatever is there in tomorrow's session. Okay, so in tomorrow's session, so if you see in these slides for today, there was nothing related to column families, how your HBase is storing data. So that's there in the next module. Okay, so we have already discussed that. Okay, so tomorrow we will focus on Zookeeper. We will focus on some how to use HBase, some command line shells. Right. So guys, we'll stop for today. Right, we'll try to wrap up HBase maybe in the first 1 hour, and then we'll start with Spark. Right. So tomorrow we'll be starting with Spark. Yeah, so Minesh, yeah, I will be showing how to use HBase, right? I would be creating a table, I would be inserting some data, fetching some data. I'll show you that example. Okay, I'll show you example of Zookeeper also. Zookeeper is not a part of a detailed thing is not a part of actually HBase Zookeeper. That's see, Zookeeper is basically a administrative tool. Okay, it's not for developers. Still, I will tell you how to use it, how it stores data. Right? So we'll try to wrap up everything for HBase in tomorrow's 1 hour, and then we'll start with Spark. Right? Thank you guys. We'll stop for today. Yeah, you too, Minesh. Have a nice evening. Just a reminder, guys. Don't forget to fill in the surveys. All right. Okay, guys. Thank you. Have a good night. If you have any questions, I'm still available for the next 5 minutes. Okay, so you can ask the questions. Yeah, so Chaitanya has a question. Can HBase work without Hadoop? It can work, but it is just for development purpose, Chaitanya. I mean, you cannot deploy that to production. Just if you want to try using HBase, so yeah, we can use without Hadoop also. Yeah, so Kodandara says, so we need 2 more days to complete the course from your side, right? Ideally, yes, 2 more days. Okay, let's see how, I mean, so Kodandara, it basically depends on what types of questions we are receiving on Spark. Because the more questions, the more time consuming, right? Because, so let's see how Spark goes. So if Spark takes time, then we will decide in the next week what to do. Okay, so Rahul says how HBase work without Hadoop. Okay, so Rahul, if it's working without Hadoop, so it basically stores your data in your local file system, right? It uses your local file system for everything is local. Your Zookeeper is also local, HBase, H files are also local, everything is local. Okay, so again, it is just meant for development purpose if you want to try your hands with HBase. But if you want to deploy it in production, then you have to use it on your real Hadoop cluster. Yeah. Yes, Kodandarao, I understand. So Kodandarao says, I'm not in a hurry, but thinking whether we are covering up everything or not, because the inputs you are providing really helping us for future explore from our side. Yes, Kodandarao, that's why I said, right, it depends on what types of questions we receive on Spark, because I will not leave anything. Okay, I will cover everything, don't worry. So even if by chance Spark takes up a lot of time, because Spark is relatively very new and everyone is very excited about Spark. So if it takes a lot of time, we may spill over to next Sunday also. But we will complete everything. Oh, great. Yeah. So data analytics with R programming and data science. Yeah, it's a good course. Yeah, it's a good course. Nice, nice. So if you start working with Spark and all, Spark will also give you a capability of R. You can run R programs on Spark. Yeah. So that would be a good use of both of the courses. Okay, so Chaitanya says, sorry, what is that course? So that course is basically, Chaitanya, it is data analytics with R programming. It's a data science course or statistical analysis and those things. Machine learning, statistical analysis. Alright, guys. So I'll be disconnecting. Have a good night. Yep. Good night. Bye.